talk about the energy, speed, and mass lab. Again, we're going to talk about the energy, speed, and mass lab. So here's our introduction with the background information. You might not be afraid to stop a marble rolling down an incline. Remember, an incline is just something that is like a ramp, okay? But if it was a bowling ball, you probably would get out of the way. Both objects are rolling because of Earth's gravity, yet the bowling ball has much more energy. The potential energy of an object is like the product of its mass, acceleration, and its height. In this lab activity, you will accelerate 4 different masses to the same speed. Really, today we're only going to do 3 different masses because of the setup, but we'll get the same data. Then you will compare their kinetic energies. If you do not have the materials to simulate this lab, watch Mrs. Tomlinson do the activity here. So I've given you a link. Just click here or click here and watch Mrs. Tomlinson do the activity so you can gather your data in class. What you're trying to think about, the main question is, what is the effect of mass on kinetic energy? So our materials are going to be some plastic bottles, a ramp, some masking tape, a meter stick. Regardless if you're doing this at home, if you want to actually set it up, which is actually kind of fun, go for it. Here's the procedure. Here's kind of what it looks like to set up. You can check Mrs. Thompson's video to see the setup. There's a lot of steps for the procedure, but as we do the lab, I would ask you to collect some data, and I really recreated this for you in the notebook page that you just filled out, and so you can see this pretty simply. And then I do want you to look at a graph, but you do not have to complete this graph. Some questions that I'd like you to think about during the lab. And you'll be able to, there's a link to this in the video, so you'll be able to see them a little bit better. But some questions I want you to think about is, what procedure was followed to make sure the bottle would be moving at the same speed each time it collided with the cup? So what did I do in the video, or what part of the procedure made sure that the bottle was moving at the same speed? Okay. Number 2, why is it important that the bottle have the same speed each time it collided with the cup in order to measure the effect of mass on energy? So remember, we're just talking about mass and the effect it has on energy. So really put some thought into that. I actually put the answer in your notebook already. Number 3 says, as the mass of the bottle increased, so as it got heavier, as the grams got bigger, what happened to the distance that the bottle moved the cup, and why? Why don't you think about that? Number 4, was the distance the cup moved related to the bottle's kinetic energy? And explain. So remember, the bottle's kinetic energy is motion, right? Was the distance the cup moved related to the bottle's motion energy? And I want you to be able to explain that. And then number 5 says, describe 2 instances in this activity that could represent kinetic energy and 2 instances where potential energy existed. So I want you to think about that, because clearly we're going to use gravity. We have a ramp going on. We have a collision going on. We're using 2 different types of materials to indicate and measure how far that cup goes. So we have an action force and a reaction force going on there. So we're using a bottle and a cup, and you probably would use that for number 5 for your examples. All right, watch the video, collect data for the lab, finish your notebook page, and then answer the questions in the Google form to finish your lab. Have a great day.